Hello everyone. So, how are you all, dear students, and how about your studies going on? Yes, hope it's all good. Come on, that's really nice of you. Come on, guys. Once again, a very, very warm welcome to you all to your very, very own channel. Let's crack NEET UG in English. Myself, Sharada Alok. I have been teaching chemistry at Resonance from past 10 years. Can you see the link over here? Yes, guys. Using this link, you can join us on Telegram. Come on, guys. How you can get connected to us? First of all, go to Play Store, download the Unacademy Learning app, and then click on to NEET UG, and straight away go ahead for the subscription. You'll be getting two type of subscription. One is Plus subscription, and the another one is Iconic one. Let me tell you about Plus subscription first of all. Here you'll be getting daily live classes by the top educators across the nation, where you can chat with your educator, engage in discussion, ask all your doubt, and answer in the poll while all the class is going on. Come on, you'll be also getting live tests and quizzes. Come on, it will evaluate your preparation with regular mock tests and quizzes, and you'll be getting detailed analysis of your performance. You'll be getting structured courses, and all our courses are structured very much in line with the exam syllabus, which will help you to prepare your best for it. So, all by having one subscription, you get access to all our live and recorded courses, which you can watch from the comfort of any of your devices. Now, this is all about Iconic subscription, which will definitely take your NEET UG preparation to the next level with personal coach. Come on, guys, the top educators across the nation will be your personal coach, and you are going to get one-on-one guidance from top exam expert as your personal coach in order to align your preparation strategy. Along with all that, you'll be getting an in-depth test analysis with personalized feedback, which will definitely improve your time management and, of course, exam approach. You will also get a proper study planner, all designed by the top educators across the nation. It relays your preparation with customized study plan. You're going to get a bi-weekly review that will definitely highlight your progress. So, all by having one Iconic subscription, you'll be getting live classes from top educator, mock test and quizzes, structured batch courses, very much in line with exam syllabus. So, guys, you must be wondering whether to go for Plus subscription or the Iconic one. I just want to tell you, whatever you are going to get under Plus subscription, you are going to get all that under Iconic subscription. So, choice is all yours. You need to select a plan that suits you. So, guys, and under Iconic subscription, you'll be getting personal coach, study planner, expert guidelines, and of course, in-depth test analysis. So, guys, you must be wondering how much you have to pay if you want to go for Iconic subscription. Let me tell you here itself on the screen. Guys, you can go ahead either for 6 months, 12 months, and 24-month subscription. For 6 months, you'll have to pay 38,000. For 12 months, you'll have to pay 65,000. And for 2 years, you'll have to pay 1 lakh. If you apply this referral code of mine, you will have to pay much less amount. Yes, guys, for 6 months, you'll have to pay 34,200. For 12 months, you'll have to pay 58,500. And for 2 years, you'll have to pay 90,000. Come on, guys. I just want to tell you, all those who are in class 11 or 12 or 13, guys, class 11 should go for this 2 year subscription. That would be best for them, but I just want to recommend personally to all those who are who have taken dropper or class 12 student must go for the 6 month subscription by paying 34,200, which is going to cost you only 5,700 per month. Come on, this 6 month, 12 months, and 24-month subscription are also available at no cost EMI. So choice is all yours. Now let me tell you about Plus subscription. Right from 1 month, 3 months, 6 months, 12 months, and 24 months, you can go ahead for which you want. Come on, for 1 month you'll have to pay 7,000. For 3 months you'll have to pay 17,500. For 6 months you'll have to pay 28,000. For 12 months you'll have to pay 38,500. For 2 years you'll have to pay 56,000, which is going to cost you 2,333 rupees per month. But if you apply this referral code of mine, you'll have to pay only 6,300 for 1 month, or 15,750 for 3 months, 25,200 for 6 months, 34,650 for 12 months, and 50,400 for 2 years, which is going to cost you only 2,100 rupees per month. So, choice is all yours. And remember, for 6 months, 12 months, and 24-month subscription, you should go ahead for at no cost EMI as well. So, you should go ahead for this, guys, because these are also available at no cost EMI. One of the very important thing, guys, whether you want to go for plus subscription or the iconic one, all those who are in class 12 or have taken drop must go for 6 month subscription. If you really want to benefit out of it and pay less, guys, must go for this 6 month subscription. That is going to help you a lot, because we have 6 month, almost minimum 6 month we have for the examination to occur, isn't it? For NEET examination, NEET 2021, at least 6 month we all have with us. So you should go for this 6 month subscription, guys. Now, guys, we are going to start this Umeed batch from 3rd of January. Do join this crash course for NEET 2021. And if you really want to prepare for medical entrance examination with the top educator, do join this Umeed batch, which is going to start from 3rd of January. Come on, this people are going to mentor you. The top educators available at Unacademy are going to mentor you, guys. Finest teaching of them are going to provoke your umeed, going to ensure your umeed for selection in NEET 2021. Dr. Anand Mani sir, Aman Kumar Singh sir, Deepak Vashist sir, Vikrant Kirar sir. Do join them from 3rd of January and ensure your selection. Come on, guys. Ummeed batch. Once again, have a look at them. Dr. Anand Mani sir, Deepak sir, Vikrant sir, Aman Kumar sir are going to mentor you under this batch for NEET 2021. So do join this so that you can start your preparation in order to ensure your selection. We are starting one more batch, that is Super Ranker batch for NEET 2021. It is going to start from 28th of December. It is a crash course for NEET 2021, guys, preparation of NEET 2021. And yes, if you really want to ensure your selection, and then do join this and start prepare for this, guys. Prepare for medical entrance examination with top educators. Let me tell you who all are going to mentor you under this super ranker batch, guys. Ashish Diwan sir, Pankaj Talwar sir, Ritu Ratewal, Ma'am Pradeep Chatora sir, Rohit Kumar sir, and the batch is going to start from 28th of December. Come on, have a look at the top mentors, guys, who are going to mentor you for this batch, guys. Ritu ma'am, Pankaj sir, Ashish sir, Pradeep sir, and Rohit sir. Do join them. This is actually, they are going to make you prepare for NEET 2021. So, guys, let us start, for which you all are gathered here. Yes, guys, in continuation to the series started by me on NCERT discussion, guys, this is one more edition on biomolecules, that fourth session under biomolecules. And the very first question which we are going to discuss on the screen is, proteins are, come on, the very first question is, proteins are found to have two different type of secondary structure. There are two different type of secondary structure, namely alpha helix and beta pleated sheet structure. Alpha helix structure of protein is stabilized by, guys, this picture is of alpha helix structure before you on the screen. This looks like telephone cord. How does it look like? It looks like telephone cord. This is actually the shape of telephone cord, shape of the alpha helix, guys. Remember, this is telephone cord shape, and it looks like telephone cord shape, guys. And why does it look like so? This alpha helix is actually held by hydrogen bond. And remember the hydrogen bond, how does it form, guys? This is formed between CO group of one amino acid and NH group of another amino acid, which is present at fourth position down the chain, guys. This is first, then this would be the fourth amino acid. This NH group would be the fourth amino acid down the chain, guys, down the chain in the next turn. Guys, this one is the next turn. This should be present in the next turn. Remember of this telephone cord shape. So it is stabilized by hydrogen bonding. But you need to remember this, guys. This hydrogen bonding is intramolecular hydrogen bonding, which is actually formed between CO of first amino acid and fourth group of like NH group of fourth amino acid down the amino acid chain. And yes, it is present in the next turn of the telephone cord helix. Okay, guys, come on. It is clear to you. Have a look at the screen. Remember, guys, This NH group and oxygen, this oxygen of CO, they are attached together by the hydrogen bonding, intramolecular hydrogen bonding. Okay, guys, remember there are four amino acid down the chain. The difference between these two hydrogen bonding is of roughly four amino acid, and there are typically, if you talk about the number of amino acid, typically in alpha helix, it is about 11 amino acid long. Come on, guys, questions are asked from, like, can be asked, have been asked from any of the topic, any of the small topics. So whenever you are studying them, you need to be very careful. All you should ensure that you are sitting with your pen and copy in your hand. Your eyes should be there on the screen. And yes, all those who have not liked the video so far, do like the video, do share the video to all your friends who are preparing for NEET 2021 KVPY board examination. It is going to help them all. And all those who are watching the channel for the first time or have not subscribed the channel so far, do subscribe the channel. Let's crack NEET UG in English. Do press the bell icon in order to have further notification. Now let us have a look at the next question, guys. The next question is, what are the common type of secondary structure of protein? Guys, secondary structure of protein can be alpha helical structure, or it can be beta flat sheet, which is also called as beta pleated sheet structure. Guys, beta flat sheet or beta pleated sheet structure. Remember, guys, if R group is large, the R group attached to the amino acid, if R group is large, guys, it will be having alpha helical structure, whereas if R group is small, it will be having flat sheet or simply called as pleated sheet structure. Guys, if R group is small, it will be having beta pleated sheet structure. Then this beta pleated sheet structure looks like pleated fold of drapery. Pleated fold of drapery. Come on, guys, this looks like pleated fold of drapery. Now let us have a look in detail on both of them one by one. So first of all, have a look at alpha helix structure. Guys, just now I told you that R group should be bigger in alpha helical structure. Remember, guys, R group here, R group should be quite large. R group should be quite large. Done. Now, guys, there is intramolecular hydrogen bonding over here. Can you see here? Just have a look into the inbox, guys. These are the intramolecular hydrogen bonding between CO of one amino acid. If this is one, then this NH, this would be of fourth amino acid. Okay, guys, intramolecular, this is intramolecular hydrogen bonding, which is formed between, guys, CO of one amino acid residue and NH of fourth amino acid residue in the chain. Fourth amino acid residue in the chain, guys. Done. Now, remember, guys, because of this intramolecular hydrogen bonding, this looks like a coil because coiling is caused, guys, this intramolecular hydrogen bonding causes coiling of polypeptide chain. It causes intramolecular hydrogen bonding causes coiling of polypeptide chain into a spiral helical structure, which is actually called as right-handed. Guys, this is called as this looks like this, guys, right-handed. This is actually the helix are right-handed, so it's called as right-handed alpha helix structure. Done. Okay, guys, this is all possible. This helical structure is all possible by intramolecular hydrogen bonding between CO of one amino acid and NH of fourth amino acid down the chain, guys, in the next turn. Therefore, it looks like a coil, telephone coil shape. Okay, come on, guys. Very important thing I'm going to tell you now. So all your eyes to be there on the screen, guys. Alpha helix is also known as it is also known as 3.6 subscript 13 helix. Why? Let me use the eraser over here for a moment. This alpha helix is also known as 3.6 with a subscript 13 helix because, guys, this is very, very important. Another name of alpha helix is 3.6 with a subscript 13 helix because in each turn of the helix, in each turn of the helix, they have approximately, guys, 3.6 amino acid. Remember, approximately 3.6 amino acid, and this 13 stands for because this 3.6 alpha amino acid and a 13 membered ring. Because of the intramolecular hydrogen bonding, it looks like a ring as well. So guys, approximately 3.6 amino acid are bonded by intramolecular hydrogen bonding and get enrolled or get coiled up in a 13 membered ring. That is the reason, guys, the 13, the meaning of the subscript 13 over here is from 13 membered ring. And this is all formed by intramolecular hydrogen bonding. All clear, guys? Remember, you have to remember which all points over here. First of all, this alpha helical structure is found where R group is large. The second one, intramolecular hydrogen bonding is formed between CO of first amino acid and fourth like NH group of fourth amino acid. That too should be present in the next term. Done, guys. And this alpha helix is also called as 3.6 with a subscript 13 helix, where 3.6 stands for approximate number of amino acid, molecule of amino acid, and 13 stands for the 13 membered ring. Now let us have a look at beta pleated structure. Beta pleated sheet structure. Come on, guys. Here, beta pleated sheet structure. First of all, the points which are to be remembered over here is here R group is small. R group is small. And secondary, guys, this is a simple structure. This one is simple, more simple than the helical structure, guys. Alpha helix. Okay, come on, have a look at the screen inbox over here. Guys, here what is happening? Can you see the polypeptide chain? This is polypeptide chain 1. This is polypeptide chain 2. Come on. These two polypeptide chain, or there are many such polypeptide chain, guys. These polypeptide chain lie side by this here this is intermolecular hydrogen bonding, guys. Okay, these polypeptide chain lies side by side in a zigzag. Can you see the pattern, guys? Here they are arranged in a zigzag manner with alternate R group, guys. Alternate R group. Can you see the alternate R group over here? Guys, the alternate R group are on same side. Come on, these two R group are facing each other, guys. They are on the same side, situated at a fixed distance from each other. This distance is fixed, guys. Remember, alternate R group are facing and the rest alternate R group are opposite to each other. Can you see these two R group? They are opposite to each other, whereas these two R group are facing each other. And yes, they are equally distant, guys, because of the intermolecular hydrogen bonding. They are present at equal distance with respect to each other. Remember, this is very, very important points to be remembered over here about beta pleated sheet structure. Clear, guys? Now remember one thing, these two polypeptide chains are connected together by intermolecular hydrogen bonding. And because of this, looks like a pleated fold of drapery. Guys, beta pleated sheet structure is called so because it looks like like pleated fold of drapery. It looks like beta pleated. It looks like pleated fold of drapery. Therefore, it is also called as beta pleated sheet structure. Remember, guys, because it looks like pleated fold of drapery. It is called as beta pleated sheet structure. Done. Now, guys, remember two such chains are held together by intermolecular hydrogen bonding, and so many such chains forms a sheet. So many such chains join together in the form of a sheet, and so many sheets are stacked over one another just like pages of book. Okay, guys, this gives this a 3D appearance. So it looks like pages of a book. It looks like pages. The 3D form looks like pages, guys, of a book. It looks like a book. Okay, guys, hope it is clear. So remember one thing here, R group is small. This is simpler structure. And guys, here intermolecular hydrogen bonding actually joins the two parallel polypeptide chain which are arranged in a manner where alternate R groups are facing each other, and these, because of this intermolecular hydrogen bonding, they are present at a fixed distance from each other and gives looks like a sheet. So many such sheets, actually so many such polypeptide chain looks like a sheet, and so many sheets which are stacked over one another looks like pages of a book. And this is the 3D appearance of these pages of the book. That is beta pleated sheet structure looks like pages of the book. Come on, guys. Now the next question on the screen is, what type of bonding help in stabilizing the alpha helix structure of protein? Come on, have a look into the inbox here, guys. See, alpha helix structure, just now I told you that hydrogen bonding, due to hydrogen bonding, they acquire the shape of a telephone cord, which is actually called as alpha helix. So in this, what happens, guys? CO group of residue of first amino acid, hydrogen bonded with NH group of residue of N plus 4, that is fourth amino acid in the next turn. Done. Is that clear? This N means first amino acid, N plus 4 means fourth amino acid. Okay, guys. So this is CO of this. Suppose this amino acid is the first one. So, guys, this is CO of first. Then there is a gap of fourth C. This will be the NH of the fourth amino acid. Done. Is that clear? Have a look at the screen. So it is all because of the hydrogen bonding. So they get stabilized by intramolecular. Remember, guys, this hydrogen bonding is intramolecular. Intramolecular hydrogen bonding, whereas in beta pleated sheet structure it is intermolecular hydrogen bonding. I hope you know the differences between intramolecular hydrogen bonding and intermolecular hydrogen bonding. Guys, the session is already taken on it. Link for the same is already given in the description box. You must go there, just use the link and get a playlist of all my videos so far, and you'll be getting this video as well on differences between intra and intermolecular hydrogen bonding and how this affect so many properties of the respective molecules. It is all there. Go to the link, download it, watch it, and yes, if you have any doubt, you can ask me. Come on, guys, have a look at the screen, and if you have not liked the video so far, do like the video. Do subscribe the channel if you have not done so. Do press the bell icon if you have not done so. And the most importantly one is, just share this video to all your friends who are preparing for NEET 2021 KPPY and board examination. Come on, guys, have a look at the screen for a moment before we go for this next question. Yes, guys. Now the next question on the screen is differentiate between globular and fibrous protein. Come on, guys. Before we know the differences, just have a look at them. How do they look? Guys, globular protein and this is fibrous protein. Have a look at them, first of all. Isn't it looking fiber kind of? Guys, thin thread-like structure, fiber. Can you see the fibers thread-like structure like this? So guys, the one which is actually looks like a thread-like structure, which is having a thread-like structure is fibrous protein, and the one which is globe-like structure, globe, spheroidal, spherical, that is a globular protein. Now let us know the differences between them. So guys, fibrous versus globular protein. Let us have a look at the differences between them. First of all, guys, have a look at the screen. Globular protein and fibrous protein. Guys, just now we had seen that secondary structure of protein are of two types, alpha and beta pleated. Alpha helical structure and the other one is beta pleated structure. So guys, globular protein is alpha helical structure. Therefore, it looks like spheroidal, isn't it? Whereas fibrous protein, guys, this looks like what? This fiber, guys, thread-like structure, you can say thin sheet-like structure, isn't it? They have beta pleated sheet structure. Now the second one is globular protein are soluble in water. How to remember this, guys? Soluble, guys, soluble. In Hindi, soluble means ghulna. Ghulna, right? Soluble. Guys, G for globular. G for Ghulna. If you write this Ghulna in English, English alphabet, it will look like, it will be spelled as Ghulna. Ghulna. Ghu. So G for Ghulna and G for globular. Done. G for Ghulna and G for globular. I hope you are not going to forget this solubility any longer. Globular. Done. So guys, globular protein are soluble in water. Now fibrous are just opposite to this. They are insoluble in water. They are F for fibrous, F for firm. Firm means do not dissolve. Okay, guys, you have to simply relate it. There is no logic, but it is going to make you remember at the time of examination or whenever you will be getting confused between the two. It is going to make you remember all these points. Okay, so these are very illogical logical trick. Okay, seems illogical, but logical in with respect to, yes, they are going to make you remember all these at the time of when you will be getting confused. They will give you firmness, they will give you more confidence. Okay, they will prevent you from getting confused. Okay, guys, come on, have a look at the screen. So the third difference, guys, they are cross-linked condensation polymer of acidic and basic amino acid. If alpha helical structure, it has to be cross-linked. Why? Because of the intramolecular hydrogen bonding. That's it. And here you had seen that beta pleated sheet structure, they have to be linear condensation product. We have already seen how the polypeptide chain are attached together by intermolecular hydrogen bonding. So it has to be linear. This has to be cross-linked. So once you remember, guys, globular, globe-like, spheroidal, helical, that helical, because of the helical structure, they are getting an appearance of globular or globe kind of spheroidal appearance. You're not going to forget it. Okay, now the next one, guys, they are folded to give rise to 3D spherical shape, that is spheroidal shape, globular shape, globe-like shape. Done. And they have got long linear protein chains form tree-like structure. Guys, fiber, guys, a tree. How does a tree look like? Come on. A tree look like this, where this fiber will have branches, more branches. They are further having branches like this, isn't it? So, therefore, this fibrous look like a tree. Hope you will not forget this, isn't it? Come on, guys, let me tell you a few more differences between the two. First of all, I hope you're not going to get confused how to recall it, guys. The one which look like a globe is globular. Then the one which look like a spherical globes are what? Spherical in shape, so globular. Then, guys, so they have almost spheroidal shape. The one which are globular protein have spheroidal shape, guys. Okay, and why it is possible? Because of the folding of polypeptide chain by intramolecular hydrogen bonding. Done. We have already discussed this globular gulna. Gulna means water soluble. Okay, guys. Now one of the very important difference between the two, guys. These are very sensitive, very sensitive to temperature as well as the pH, guys. That means what? That means by changing the pH, by changing the increasing the temperature, they are going to get denatured. They will get denatured. And it is possible because they are very simple. I mean, guys, they are easily soluble. They're easily getting dissolved in water. Therefore, they can easily, get denatured by change in temperature or by change in pH. Okay, guys. Albumin, white egg albumin get denatured on heating. We get a solid egg albumin. Okay, do you remember that egg part? On boiling, what happens? That liquid albumin, transparent albumin get turned into a solid white substance, isn't it? That is actually happens because of denaturation. Simply, guys, casein milk, the casein protein present in milk, get denatured and causes curdling of milk, isn't it? Now remember, so on heating or by changing temperature and pH, okay, they get denatured. Remember. Okay, guys, I hope you are not going to forget this, that globular one, which is gulna, get soluble, are sensitive as well. Okay. Okay, guys, because if they are not formed to water, they can, how can they be formed to temperature, or how can they be formed to pH? This is how you have to recall this. Okay. Now, guys, globular protein possess biological activity. They do possess biological activity. For example, guys, enzymes and hormones. Enzymes and hormones. Guys, enzymes like maltase, invertase, come on, note it down. Enzymes like maltase, invertase are all globular protein. Hormones like insulin, antibodies, guys, they are all what? They are all what? Globular protein. And yes, hemoglobin, globulin, that way you have to recall this. Hemoglobin also coming under globular protein. Remember, these examples are mostly asked that which of the following are globular protein. So guys, once again, I'm reminding you, enzymes and hormones, enzymes like, yes, maltase, invertase, hormones like insulin, antibodies, okay guys, and transport agent like hemoglobin, okay, albumin, these are all globular protein. Now guys, let us look for fibrous protein. So guys, fibrous protein, basically they are insoluble because they are firm. They are firm. They are firm means they are firm to water. They are not going to solubilize. So remember what, where do they present, guys? They are present in fibroin. They are present in collagen, myosin. Guys, firmness. They provide firmness. They provide, wherever they are present, they provide firmness. And firmness is required outside of the body. Remember, this is how you need to learn them. Outside of the body means keratin and skin. Keratin and skin. Skin is what? Outside of the body. Hair, nails. These are what? Keratin present in skin, hair, nails, and what, guys? Wool as well. These are all what? Outside the body. Now, collagen in tendons. Collagen in tendons, guys, which provides what? Firmness. Fibroin in silk. myosin in muscle. These all provide firmness. So guys, the one which is providing firmness present outside are what? Fibrous protein, mostly present outside, and globular one like enzymes, hormones present inside the body. Done. I hope you are not going to get confused between the two. Globular, gulna, globular, one very sensitive. The one which is not firm to water is very sensitive to temperature, not firm to temperature, not firm to pH as well. And the one which is firm to water is firm, provide a firm structure, fibroin, keratin of skin, hair, nails, collagen of tender, firmness, okay, myosin in muscles, muscular contraction. It should be little bit firm, isn't it? So hope you are not going to get confused between the differences of fibrous and globular proteins. Have a look at the next one now. Now the next is, guys, each polypeptide in a protein has amino acid linked with each other in a specific sequence. Just now we had seen the sequence of amino acid is said to be primary structure. Remember guys, the normal sequence amino acid, okay, that peptide bond formation between NH of one amino acid and CO of another. The basic sequence of amino acid is what? Primary structure of protein. Remember guys, the sequence of amino acid that comprise protein is primary protein structure. Amino acids are linked together by peptide bond, which is formed by loss of water between what? Between the two amino acid. Now different amino acid differ in side chain of R group. I've already told you guys this R, the basic structure NH2 CH and COOH are going to remain same. All amino acid are going to differ with respect to this R chain, guys, side chain. They are going to differ with respect to this R. Okay, this R can be acidic, this R can be aromatic, this R can be polar, this R can be non-polar. And I've already taken a session. I've already taken a session under the series of NCERT discussion, guys. Do go to the description box, get the link, get the playlist over there, and watch it yourself. Okay, guys. Okay, watch it yourself. The link is there, the playlist is there in the description box. Is that clear? Come on, have a look at the screen. Guys, this is the peptide bond. You can see very easily, guys, NHCO1 peptide. This is another peptide, and there are many such peptide. Therefore, guys, it is also called as polypeptide. What do we call this? We call this as polypeptide. Okay, so many peptide linked together are actually called as polypeptide. Done. So guys, here the sequence of amino acid, basically first of all it is the simple one. The sequence is called as primary structure of amine. It looks like this. Let us have a look at the next one then. Now the next one, which of the following B group vitamins can be stored in our body? How to remember them, guys? Vitamin B1, vitamin B2, vitamin B6, or vitamin B12? Guys, the answer is D. But how to remember this? Vitamin B12 can be stored in our body. How to remember this, guys? How to remember this? Let me tell you. Guys, B for BARAH, Hindi mein 12. Guys, 12 in Hindi is called as Bara, right? I know you must be wondering English Hindi chal raha hai, but anything guys, all like by either by hook or by crook. My purpose is to make you remember this so that you should not get confused. Okay guys, come on. B for Bara and B for what? B for Bara, B for body. Guys, so Bara B means what? Vitamin B12 can be stored in our body. Okay, so B for Bara B for body. Bara can be stored in the body. Bara what? Bara is B12. Guys, B12. Bara means B12 can be stored in the body. Done. Let us go ahead for the next one now. Now the next is protein can be classified into two types on the basis of their molecular shape. Guys, fibrous protein and globular protein. We have already seen the differences between the two. Now, which of the following are globular proteins? Just now I told you guys, globular means gulna, inside the body, isn't it? Fibrous, firmness, mostly outside the body. So collagen, keratin are all fibrous one. Myosin, okay, myosin are all fibroin, are all fibrous, isn't it? Now, globular protein are globin, hemoglobin, insulin, catalase, okay, guys, maltase, enzymes and hormone, insulin, antibodies, enzymes, maltase, invertase are all coming under what? Globular protein. Done. So, guys, here, which all are examples of globular protein? Tell me. Very easy. It is insulin and albumin are globular, whereas keratin and myosin are fibrous protein. Firmness, fibrous protein, guys, skin, nails, they have what? They have to do what? They have to provide firmness to the that particular part, isn't it? Nails, hair, skin. So hope you are not going to forget this. Come on, guys. Now the next one is which of the following carbohydrates are branched polymer of glucose? Which of the following carbohydrates are branched polymer of glucose? Amylose, amylopectin, cellulose or glycogen? We have the option over here in front of us. Now, which of them are branched polymer of glucose? But before that, I just want to tell you all, if you have not liked the video so far, do like the video. If you have not shared the video so far, do share the video to all your friends who are preparing for NEET 2021, KVPY and board examination. And all those who have not subscribed the channel, Let's Crack NEET UG in English, do subscribe the channel, do press the bell icon in order to have further notification. Okay, come on, let us see the structure. Guys, amongst them all, it is amylopectin and glycogen, which are having branched polymer of glucose. Remember. Done. It is amylopectin and glycogen. And the structure before you is of amylopectin. This is of amylopectin, guys. Remember, amylopectin and glycogen both have branched chain structure. But how do they differ, guys? There is a difference. Guys, they differ only in the number of glucose units they have in the chain length. Remember. Now, amylopectin, guys, are branched. Can you see this is the straight chain where this is a 1,4 linkage, guys, straight chain glycosidic linkage, alpha glycosidic linkage, that is alpha glucose, alpha glycosidic linkage, guys, 1,4 linkage is there. Now, guys, these two chains are further actually joined together by this branch, which is 1,6 branch, guys, 1,6 branch over here. Done. So, guys, these amylopectin basically consist of 1,4 in the chain and 1,6 in the branch linkage. Done. Now, remember one thing, guys, there must be 25 to 30. 25 to 30 D-glucose units are there in the chain of this amylopectin. 25 to 30 D-glucose units. Done. And remember, this amylopectin are insoluble in water. Insoluble in water. That gives violet color with iodine. Clear, guys? Come on. Come on, let us have a look for the structure of glycogen. Is this clear, guys? 1,4 and 1,6 branching. 1,4 is an alpha glycosidic linkage in the straight chain, whereas two chains are branched together by 1,6 linkage. Done. Have a look at the next one now. So, guys, the next one is glycogen, which is also having branched chain structure. Okay, can you see here the same type of structure, guys? Glycogen also have structure like amylopectin, same like amylopectin with a little difference, guys. It is like amylopectin, remember. With a little difference, guys, the little difference is, please note it down. Here branching takes place after every 5 to 6 glucose unit, remember. And remember, guys, this branch ends with, can you see the inbox, guys? Here, the branch ends with a non-reducing sugar. Okay, and here also the linkages, guys, the straight chain linkage is 1, 4 and the branching is 1, 6. But the only difference, guys, the branching takes place after every 5 to 6 glucose unit. So amylopectin and glycogen both have branched chain structure, but they do differ in with respect to the number of glucose unit in the chain length only. Hope it is clear, guys. Come on, have a look at the screen for the moment. So guys, thanks a lot for watching. All those who have not liked the video so far, do like the video, do share the video. And yes, if you have not subscribed the channel so far, do subscribe the channel. Do press the bell icon in order to have further notification. And do take the subscription applying this referral code of mine. Thanks a lot for watching. Keep rocking, guys. All the very best to you.